Hello, my darlings. This is page 1 of segment relationships in circles. So this is a mix of chords and tangents and secants, so it's dealing with all of them. So the first one is the secants of chords theorem, which says if we have two chords that intersect at a circle, the two pieces that are formed by each chord, they're proportional to each other. So A times B equals C times D. So example 1a, to solve for x, we're basically saying part times part equals, for the other chord, the part times the part. So 14 times x equals 12 times 21. 14x equals 252. Divide by 14 and x equals 18. So again, same example 1b. First chord, you have the part times the part. Second chord, you have the part times the part. So we get 9 times x equals 6 times 6. 9x equals 36. Divide by 9 and x equals 4. All right, the next theorem is called the segments of secants theorem. So we have secant segments. Remember, secant segments cross through the circle and intersect it twice. Okay. So in this case, what happens is it's the part times the whole equals the part times the whole, but it has to be the outer part, the part that's outside the circle. So A times B equals C times D. All right, so looking at example 2a, the parts are 6 and 5. The whole, we'd have to add the 6 and the x, and we'd have to add the 5 and the 7. So we get 6 times x plus 6 equals 5 times 5 plus 7. So I'm going to distribute my 6, and I get 6x plus 36 equals 60. Subtract 36 and get 6x equals 24. Divide by 6 and x equals 4. All right, so example 2b, same idea again. So the outer parts are 7 and 8. The whole thing, we'd have to add 7 and x, and we'd have to add 8 and 13. So I get 7 times x plus 7 equals 8 times 8 plus 13. So I distribute my 7. So I get 7x plus 49 equals 168. Subtract 49, and I get 7x equals 119. Divide by 7, and I get x equals 17. And that's the end of page 1. Log back in to see page 2.